Hi class. So this is the review video for the Half-Life lab. Remember, these handouts that you have can be used on the final on Wednesday next week. Okay, so what do we do in the Half-Life lab? In this section, we were talking about nuclear reactions and how things can break down. Atoms that are unstable can break down at certain rates. And the way scientists quantify this is by calculating how long it takes for half to break down. That's why it's called the half-life. The half-life is actually a time. The amount of time it takes for half to break down. So obviously in the lab we can't give you radioactive substances, right? Things that break down, because that would cause you mutations to your DNA. So we used pennies to study half-life. I gave you a bag of 50 pennies and you had to flip them, and for every one that was heads, you kept it because that was the radioactive one. And if it turned out tails, you removed them because these were the ones that already broke down. So as you can imagine, 50% of them, right, there's a 50% chance it'll turn heads or tails. 50% of them will turn up heads, and then the population will be cut by half on each iteration, on each time you do it. So we have this sample data that you start off with 50, and then it's about half every time. You notice it's about from 50 to 26 is about half, 26 to 12 it's about half, and then 5, and then 2, and then 1, then eventually you'll get to none. Right? Some of you ended a little bit earlier, some of you ended a little bit later, 7th, 8th, or 9th half-life, but it ends up probably being about 6 every time. So now you have to graph the data. So we're going to graph half-lives on the x-axis. I'm going to spread this out a little bit. 1, 2, 3, 4, 5, and 6. And I'm going to label this half-life number of half-lives. And then we're going to label the number of radioactive isotopes remaining on the y-axis. So I'm going to put 50 up here, and it's going to be every 10 for every 2 marks. You always have to space it out evenly. And now we graph the data. So at 0 is 50, and at 1 is 26, which is about right there. 2 is 12. 3 is 5. 4 is 2. 5 is 1. And 6 is 0. And you'll notice it looks like this curve that eventually leads to 0. Right, mess that up down there. Ignore my bad sketching there. You can do much better on your paper. And so this is called exponential decay. Anytime you have something that leads to 0 progressively faster. And this is what happens to radioactive substances. So we take a look at these sample problems, and you can see what we're talking about. If you have 50 particles of a radioactive substance, how many will remain after 2.5 half-lives? So we look at 2.5 on this graph, and it's about 8, maybe, right? You can do this through a calculation, but you don't have to do that. On this, on the test, you will be able to just divide by 2. In this case, you have to look at the graph. So 2.5 lives is about 8 particles. So if you look at this question, it says if you have 125.0 grams of a radioactive isotope, how much will remain after 3 half-lives? So if you write 125.0 to start with, and you go through the first half-life, you'll have 62.5 grams at the end of that. And then at the end of the second half-life, 2 half-lives, there'll be 31.25 grams. And then at the end of the third half-life, 15.625 grams. Just dividing by 2 each time. So if you wanted to get the sig figs right, you want to make sure that they all have 4 sig figs like the first number. You put a 0 after the 62.50. The third one is correct, and the last one you would round to 15.63 grams. And on the final sample problem, you have 80 grams of a radioactive substance, and the half-life is 5 days. How many days will it take to have 110 grams remaining? So you have to think about, if you have 80.0 grams to start and 10.0 grams to end, you have to think about how many half-lives it takes to get from there, from 80 to 10. Well, the first half-life is 40 grams. The second half-life is 20.0 grams. And the third half-life would be 3 half-lives. It takes from 20 to 10 grams in that last half-life. So it's 3 half-lives. Now each half-life is 5 days. So this one would be 5 days, and that one would be 5 more days, and this one would be 5 more days. So you add those up and it's 15. Obviously you could do the multiplication as well. 3 times 5 is 15. So it's 15 days is the number of days it would take to go from 80 grams to 10 grams. So I hope that was a good summary for you for the final. And I'll answer any questions before the final on Monday or Tuesday. Thanks, and have a good weekend.